responsible for knowing which one's an artery and which one's a vein. And you're responsible for knowing the 3 different layers that compose them, okay? So first we're going to go over the layers, because these will help me in explaining which one is which. So the layers are called tunicas, and it's just the inside, the middle, and the outside. Kind of like we saw when we were dealing with the organ histology at the beginning of the semester. When you see a tissue type change, that's when you get to a new layer, okay? So in this vessel here, we have that really dark inside layer. That's the tunica interna, okay? And what type of tissue do you think makes that layer up? Epithelial tissue, great. Then we have the tunica media, which is this middle section. Who wants to guess what makes that up?
Wait, what section?
This section here. It's a muscle. Smooth muscle, right? So we smooth muscle. Good. And then this outer layer here, that would be the tunica externa. And what general type of tissue makes that up? What do you think? So you don't have to give any specifics. What general type of tissue? We have epithelium, muscle in the middle, connective tissue, right? It's going to be nervous tissue, so that's the one that's left. Got connective tissue on the outside. Perfect. So those are the general layers. Specifically what we see here, darkly stained, those are going to be elastic fibers. You see a lot of elastic fibers in these because you're going to have a lot of pressure, right? Which vessel, veins or arteries, would you expect to have more pressure? In the arteries, right? So you would expect to see a more concentric and tightly packed, like more functional, basically, elastic layer, usually thicker in arteries. So you're going to see differences in those outer layers that can help guide you towards whether it's an artery or a vein. There are 3 general ways that I like to tell the difference between a vein and an artery. First, with an artery, you do have higher pressure, right? That's usually associated with a thinner lumen. Okay, so if you look at the lumen of a comparable vein and artery, you would expect the artery to have a smaller lumen. Okay? Additionally, you would expect the artery to maintain its shape better. So it's going to be more circular, whereas veins are going to be more oblong. They don't maintain their shape as well. And that has a lot to do with the pressure and the fact that you have this nice, thick, elastic tissue surrounding the artery, right? It's the artery if you can get there. And opposed to the vein here, you can see we do have some elastic fibers, but it's not as well defined as we see with our artery, okay? And then, let's see, yeah, I mean, those are definitely like the 2 ways. Just bigger center here, not circular, okay? You can sometimes see differences in the walls, like I pointed out too. You'll expect to see more elastic fibers in the artery, but more muscle in the veins. These ones are about even, so again, like I always say, try to get like 2 of the 3 rules. You often see a thicker muscular wall in the veins because whereas the arteries are more concerned with not bursting, the veins need to have a little more musculature so that they can help pump the blood back up to the heart, right? So they can do little contractile pulses in order to assist in getting blood back up to the heart. But the elastic fibers obviously aren't that important because the pressure is so low. Okay, and also if you're trying to find these, a good indication that you found veins and arteries, you'll often find blood still in the vessels. So we have on the inside right here are actually red blood cells. Now, you're responsible for knowing veins, arteries, and capillaries. There's a level of organization in between veins, arteries, and capillaries that you aren't responsible for. You aren't responsible for identifying arterioles and venules, okay? So an example of that would be this smaller one right here relative to the 2 big ones. We can tell that this is a vessel. That wouldn't be tested at all though. You're not responsible for knowing arterioles or venules. They're too small, and when you get that close to the capillary beds, the arterioles and venules are actually very similar in their wall composition. So we don't get enough detail at that level to really decipher whether it was an artery or a vein. But we do need to know capillaries. Now with capillaries, are we going to have all of these layers? No, right? capillaries just have a simple squamous epithelial ring around them. So really what you're gonna be looking for, the two ways that like you can tell that you found a capillary, is that you have a thin wall. We'll zoom in on this one. It's kind of like ghost looking shape right here is actually a capillary. That one's actually a fairly large capillary. You can get capillaries as small as 2 simple squamous epithelium cells long or wide. So they can be really, really tiny. But again, they can range, this one's probably in the neighborhood of like 7 to 10. So you can find capillaries that are larger like that one. But the key is just that it's simple squamous epithelium. Another way that you can sometimes tell is that if you zoom in enough, you can sometimes see red blood cells inside of these guys as well. Here's our capillary zoomed in. Again, you can see that it's just a single layer of cells, okay? When you get slides, some of them definitely have, I've found, like really great arteries and veins or really great capillaries, but I haven't found too many slides that have both in one. So don't hesitate to come back and switch them out a few times if you don't really get a good grasp of what these things look like, all right? Okay, any questions before we move on to aorta? Okay, so with the aorta, it's going to look a little bit different than we were actually. It's going to look a little different from what we were just looking at because the aorta is an artery, but it's the first artery to come off of the heart. So what that means is its composition will be specialized for its function. So if we have a vessel that's the first artery off of the heart, you can assume that it's not going to be very important for it to have muscle, right? Because you have the entire cardiac muscle pushing blood through this. It would be really dumb for it to have its own smooth muscle because it would probably do absolutely nothing. So what we see mostly is elastic fibers, right? Because it's really important that that aorta doesn't burst open. So if you look at its makeup compared to what we just saw in the other arteries, there is no smooth muscle and a whole bunch of elastic fibers. So that's kind of the biggest difference we see here. This layer here would be the tunica interna, just that thin line there. And with this one, that one's not as clear, but really what you're going to look at is the two sides of the elastic tissues to figure out which one's the inside and which one's the outside, because most of the cuts that we have are big patches like this and not full lumens like we saw with the artery, because it's obviously a much bigger vessel. Down here, you can see that this is connective tissue and like typically loose connective tissue, so that's how you can like be certain that that's not going to be the lumen, because you don't find that in the lumen. So here we have our tunica externa down here. All of this is the tunica media. Okay, so the tunica media here is going to be that elastic tissue because we don't have any muscle. And then this top layer just be the tunica interna. If you get this slide though, I'd be very, very surprised if you were asked to identify the 3 layers, because it's kind of silly to ask you on something that's so specialized. You're more likely to just be asked what this is, and it's elastic. Okay? Any questions on the aorta? Great. Moving on to the lymphatic